pleasant memory is all that remains of a world with 1 or 2 horsepower. Old Dobbin would find himself quite out of place on a fast and crowded highway. The iron horse was a modern marvel when Grandmother was a girl, but now... Today, cameras and rockets 100 miles above the Earth are giving us a glimpse of what the passenger of tomorrow may consider commonplace. Well, this certainly is an age of progress, isn't it? There's been more of scientific discovery, more of technical advancement and material progress in your lifetime and mine than in all the ages of history. Invention has become the symbol of the age. And the mousetrap could well be the symbol of invention. What father hasn't said to his offspring, son, build a better mousetrap and the world will be the pathway to your door? And the sons have been busy doing just that, thinking, planning, working, and they've built their better mousetraps. For man has discovered a lot of things. And yet, perhaps the most embarrassing discovery is the fact that regardless of what man may invent or devise, nature had it first. Traps? Why, there are literally millions of them. Far more wonderful and complex than anything man has ever thought of. Between a Venus flytrap and a bear trap is quite remarkable, isn't it? The general appearance, the teeth, the action. Now, the bear trap has a trigger right there. And if that trigger is pushed... Now, the Venus flytrap has a trigger also. In fact, it has 6 of them. 3 on each side. But there's a difference. The bear trap doesn't know a bear from a piece of wood, but the Venus flytrap does. You see, to touch the trigger hair just once is not enough. Nothing happens. But if we touch the trigger hairs more than once, and at just the right intervals, the trap is sprung. You see, no energy is wasted on a twig or a leaf that might fall into the trap. But even more amazing is how those trigger hairs work. There is actually a flow of electrical current from those tiny trigger hairs to the apex of the plant. And when anything touches them, the flow of current is interrupted. A correct number of these negative impulses will cause the trap to spring. If the insect struggles to get away, more pulses cause the trap to close even tighter. Man may have thought he built a better mousetrap, but he's never built one like this. Why, the trap is also a stomach. The animal will soon be digested by the plant, and in a few days, the Venus flytrap will be open for business again. Now, that action of the jaws snapping shut, it can take place in a 25th of a second. It can even catch flies. And yet the plant is completely devoid of muscle tissue. That flow of electric current, we know it's there. And yet the plant has no nervous system. How does it happen? Someday we'll know. The plant life of North America's bogs and swamps reveals that a master craftsman has laid out with intricate design a variety of traps to serve the needs of nature. Some of the traps are passive. The trumpet plant, for example, is a type of pitfall. It's composed of a long, slender tube which will average from 18 to 24 inches in length. Down inside the tube are tiny glands that produce a nectar, and the nectar serves to attract the insects. The cobra plant is another type of pitfall, and like all the others, it may be passive, but it's very effective. The hood of the plant is a maze of tiny windows. These appear to the trapped insects to be a way of escape. In a frustrated attempt for freedom, a false step usually occurs, and the insect adds to the daily mineral requirements of a carnivorous plant. Yet another type of pitfall is the pitcher plant. The shape of the leaves is responsible for its name. The leaves actually grow in such a manner that they form pitchers. Pitchers that are 6 to 8 inches deep and as much as 1 to 2 inches wide. Most of the pitfalls simply allow the prey to follow the line of least resistance. Getting out, however, is an entirely different matter. The tiny hairs on the welcome mat suddenly become spears that surround a prison. When an insect topples in, a pool of death awaits below. The liquid will put him to sleep and then digest him. The traps always eat what they catch. Beautiful, isn't it? But these are not flowers. They're leaves of the sundew plant, nature's own brand of flypaper, and they're covered with bright red hairs. The glands that manufacture the sticky secretion are located at the ends of these hairs, and it is through these same glands that the food is assimilated by the body of the plant. Talk about your traps. This is a working model of one of the most fantastic traps ever built. Now the prey approaches, triggers the mechanism, this trap even resets itself. Now, can you imagine building all of this complicated mechanism into a trap the size of the head of this pin? God did it. The plant itself, the utricularia, lives beneath the surface of the water. Each of the small globular objects is a trap, much more complicated than our working model. The trap itself is so tiny that it will take a microscope to see it work. But if we're fortunate, we can actually see the plant trap tiny animals. Notice the guide hairs and the 3 small trigger hairs. Now, don't blink your eyes. You're liable to miss the catch. This little animal doesn't know which way to go, and he's just the kind of a fellow utricularia likes to have around. Did you see it? Well, I told you not to blink. You see, the catch is actually made in a 50th of a second. Now watch closely this time. When the trigger hairs are bent, the trap is sprung. And when an animal gets sucked inside, eventually he succumbs and is digested. Even the utricularia sometimes overeats. When we see such a complex mechanism as this, then remember it's no larger than the head of a pin, man's best traps look strangely cold and ineffective by comparison. Man's progress has not been due to discovery of new things, but merely to the uncovering of principles and devices that God ordained in nature.